In this video, we'll design a mechanical yoke using KOMPAS-3D, following a fully parametric and structured workflow. We'll move from a controlled 2D sketch to a precise 3D component. Let's get started. KOMPAS-3D, developed by ASCON, is a powerful parametric CAD platform built for industries such as mechanical, automotive, aerospace, and manufacturing. It supports complete 3D associative modeling for parts and complex assemblies, including solid, surface, sheet metal, and object-based modeling. Powered by its own geometric kernel and parametric technology, the software ensures model stability, reliable updates, and strong performance, even in large assemblies. With support for top-down and bottom-up design methods, collision detection, and integrated engineering tools, KOMPAS-3D connects design directly to production-ready documentation. In this video, we're designing a mechanical yoke using a fully parametric approach. We start with a controlled 2D sketch, where every dimension and constraint is intentionally defined. This ensures the model stays stable and easy to modify at any stage. From there, we convert the sketch into a 3D solid using a structured, feature-based workflow. Geometric relationships are carefully applied to maintain design intent and mechanical accuracy throughout the modeling process. The focus here is not just creating geometry, but creating controlled, engineering-ready geometry. With the design approach clearly defined, let's now walk through the full tutorial and see how this mechanical yoke is built step by step. To begin, open a new part document. In the model tree, select the ZY plane, which serves as our front plane, and enter sketch mode. We begin by creating a vertical center line through the origin. This will act as a construction line and define the axis of symmetry for the model. Next, we define the right half of the profile. Activate the AutoLine command. Make sure that segment type is selected as line. If not, change it in the parameters panel and draw the lines as shown. Now, we apply constraints to define the design intent. Select the Smart Dimension tool. Set the total vertical height to 185 mm and the straight horizontal length to 103 mm. Specify the other dimensions as 40 mm, 75 mm. Ensure the top arc radius is 62.5 mm. After defining the dimensions, we need to verify whether the profile is fully constrained. Enable the parametric mode option from the Quick Access toolbar. You will notice an upward-facing arrow, indicating that the profile is not fully defined and can still move in that direction. To fully constrain the profile, go to the Constraints tab and select the Point on Curve command. Then apply the constraint by selecting the x-axis line and the corresponding sketch point. Notice that the sketch profile changes color to green. This indicates that the sketch is now fully defined. To complete the profile, activate the Mirror command and select all the sketch entities. Then select the vertical center line we created earlier as the mirror axis. The geometry is automatically mirrored to the left side, completing the symmetric profile. Select the Extrusion Element command. Enable the Symmetrically command and set the total distance to 120 mm. Click the checkmark to generate the solid U-shaped body. Rotate the view to access the bottom of the part. Select this face and start a new sketch. Draw two circles centered on the origin. Dimension the diameter to 120 and 100 millimeters. Activate the extrusion element command again. Extrude this profile by 100 millimeters to create the structural base. Now we will remove material using cut extrusion command. Select the X, Y plane and start a new sketch. Using the circle tool, draw a circle at the required location and set its diameter to 45 millimeters. Apply the necessary geometric and dimensional constraints to fully define the circle. Select the Cut Extrusion command. In the Parameters panel, set the method to Through All. This ensures the bore cuts cleanly through the entire height of the part. Activate the Full Fillet command. Select the upper face as side face 1 and the lower face as side face 2. Then select this face as the central face. Click the checkmark to complete the op ratio. N. Repeat the same process on the other side. To create the pinhole, select the side face to begin a new sketch. Draw a circle. Set the diameter to 63 millimeters. Apply concentric constraint to fully define the circle. Select the Cut Extrusion command. Change the method to Through All. Click the checkmark to confirm the operation. To refine the model and improve manufacturability, use the fillet and chamfer commands to eliminate sharp edges and corners. Apply chamfers to break sharp corners around holes. Use fillets to create smooth transitions along external edges. The part is now complete. Rotate the model to inspect all features. Ensure the holes pass completely through, the cut feature is clean, and all sharp edges have been removed using fillets or chamfers. Save your work to ensure all features and modifications are securely stored. In this video, we have created a mechanically accurate, fully parametric yoke that is clean, stable, and ready for real-world application. Every feature was built with control, ensuring the design can be modified, scaled, or adapted without breaking the model. This demonstrates how a structured parametric workflow leads to reliable, production-ready components. Thank you for watching this video. For licensing, demos, or support for KOMPAS-3D, contact us at sales@DESiMinnovations.com.